Hi, everybody. This is the walkthrough video for Thursday. It is February 20th and try 3 week 1. Yellow bell work starts next week, but for this work session, please make sure you've got today's assignment and a pencil. We're still thinking about predicting probability of traits in the next generation, right? We've been talking about that for a while. Today, we're going to use this tool called pedigrees. They can help us trace alleles through ancestry and help us make predictions for the future. So today, our sign of success is using coaching to improve, and I'm also going to talk a little bit about grading. And then we're going to do an assignment called the pedigree assignment. I wanted to let you know that your job is to turn in late work in the signed contract. And then we haven't talked about this yet, but we take a weekly quiz each Friday. You can retake them for 100%. I'll talk more about those in a moment. So remember, we're thinking about surefire ways to stop learning and what we can learn from them by my colleague, Dr. Thigpen. And so one thing that his school notices is that feedback is a gift. It helps learners grow. And when we ignore it, it means that we don't learn as fast or as much. So here are common ways that learners miss out on this critical resource. They dismiss constructive criticism from teachers or other students. They choose not to revise or improve on their past work. And they memorize without seeking true comprehension. So when people ignore feedback, they miss opportunities to refine their skills and deepen their understanding. It means they don't grow. So our goal is not, we're going to stop ignoring feedback. Our goal is to use coaching to improve. So in our classroom, that means that we're going to work to welcome feedback, including me as your teacher, that we're going to revisit and improve your past work, and that you and I, in my role as a teacher and your role as a student of biology, are going to work for deep understanding. So with that in mind, I'm going to tell you about the grading system. So nearly all our work is done on paper, not all, but nearly all. And you're going to see one of these two signs or nothing on the top of your paper. This means nothing here, like no. So you're going to see this check mark or you're going to see an R with a circle. So if you get an assignment back from me and it has a check mark on it, that means it should be full credit in the gradebook. Usually for classwork and labs and major projects, it's like 5 points per day of assignment. So you're going to find full credit for that in the gradebook. If I've messed that up, come see me with the paper. We'll take care of it. Now, if you get the R with a circle back, that's not a big deal. It just means that your work is half credit. I will always tell you what to do to fix it. Sometimes this half credit mark just means that somebody has missed a couple of the key questions we're looking for to make sure that you have thorough understanding. Sometimes it means you didn't understand an instruction set and I have to help you with that. And sometimes it means you started the assignment, but you didn't finish it. So you're always welcome to submit work like that, hopefully complete, but sometimes half complete. And I will give you 2.5 points out of 5 points. And that's going to sit in the grade book until it gets full credit. So you'll turn these in. Once they're full credit, you'll get a check mark. I'll cross off this R with a circle and you'll get all the points in the grade book. Now, if you have a paper that has an entry in the table of contents, which you'll see next week, that says, hey, we're collecting this, um, that's gonna, I guess you're gonna see it tomorrow, not next week. Sorry. I'm recording this, I'm recording this on Saturday. So if there's a paper and there's no credit, that means you didn't turn it in or you really didn't do enough for me to say, yeah, this person attempted to complete this assignment. And so for nearly all assignments that you don't turn in, you're gonna get 0 points. Sometimes I'll go around and check them, or sometimes I'll say, put a check mark on it yourself. But most of the time, that's a sign that you need to turn work in. Now, to help make sure that Panther Plus assigns people who need it to services like PACE, PACE 2, PACE 3, and also so families can help track what students are turning in. If something is not yet full credit, it is marked as missing in the gradebook. That's different from other classes. So again, if something isn't all the way done, it's going to be marked as missing because the expectation is that you will complete your work for full credit. So all works from week 1 through 5 is finally due at the 6 week grading deadline. So we can do that report card in the middle of our grading period, in the middle of our trimester. This year, it's Friday, April 4th at 2:40 p.m. Turning work in on time helps make sure you get feedback in time to improve. But I did also want to let you know there may be a longer delay in grading late work. I usually sit down and grade, like I'll grade AP Bio, my morning class on Monday and Wednesday, and your class on Tuesday and Thursday. So if you turn in a bunch of papers and because your folks have noticed you have a lot of missing assignments, I'll be clear with them also. Late work gets batched so that I can focus on the other work I need to do to be a good teacher. So there might be a delay. If you haven't turned a whole bunch of work in and your folks make you stay in and you're grounded or you don't get to go do the stuff you do, that's going to be an incentive for you to make sure that you turn work in on time and that you fix the work outside of class that you have not yet done. So also, to help people make sure they know about their work, we take quizzes on Fridays starting this week. You can retake these quizzes right now in Panther Plus before the grading deadline to get to 100%, but please don't wait until the last minute to do those retakes. We also, because of the way our quizzes and tests work, we will not be showing you what you got right or wrong. So part of what you're going to have to do is think about what questions were challenging, and then we'll have some study supports to help you with that, including today you should be getting the Unit 3.1 study guide. In the meantime, how are you going to study for tomorrow's quiz? You'll either get it Thursday or Friday. So how are you going to study for this quiz? Look over the work we've done this week. You should have it back if it has been turned in. And you're going to learn from those papers, study those papers, make sure you can answer those same questions again or ones that are very similar. So all right, so where have we been? We learned this idea that dominant and recessive alleles that are in genes, they're different flavors of the genes, and we can actually find out that dominant alleles lead to some phenotypes in a heterozygous setting, and that homozygous dominant recessive alleles would make this hairless pig, right? And we also learned a little bit about what if we follow more than one gene, or what if the genes aren't simple dominant or recessive relationships. You started to learn about this with our multiple alleles assignment, which should be in the inbox, which I'll grade during today's period so you can have it to study. We're going to do more on that next week. So today we're going to think about how can we make predictions about future kids. Sorry. We're going to think about how we follow traits from ancestors to descendants, and we're going to think about how we can make predictions for future kids. So today the tool we're using is pedigrees. We use them alongside Punnett squares to be able to make models of how alleles interact to code for traits. A quick vocab review before we get going. Genotype is the flavor of genes, the two genes, one from each chromosome that families inherit. So just so we're clear, both of these genotypes make a dominant phenotype, and this recessive genotype, the only recessive genotype is little a, little a, little a, or little b, or little h in the case of the pigs, right? So the genotypes are one from each chromosome, like in the pigeons, and the letter that's on each chromosome for each of the chromosomes. Now, your phenotype is your physical characteristics. Are you a hairy guinea pig or a hairless guinea pig? What type of blood do you have? Physical characteristics are phenotypes. Hopefully that helps. So here we are looking at those chromosomes. This person is a person with Down syndrome. They have 3 copies of a chromosome, but most of the other chromosomes are typical, like in a karyotype. You get 1 chromosome from the sperm and 1 chromosome from the egg in sexually reproducing organisms. And this is a human karyotype, and this person is XY. So you can see those 2 chromosomes there. Now, we're going to take on the role today of genetic counselors. So I want to talk about this in a little bit. These are people who have studied to do both medicine and patient counseling. So people who study to be genetic counselors support people in thinking about family and medical histories to assess the chance of a disease occurring or reoccurring in people. They also do education about inheritance and testing, management, disease prevention. And then they also help people think about what they're going to do with the rest of their family. Like if you end up with a cancer diagnosis and it turns out you have a gene that makes errors in cell division much more likely, how do you reach out to other relatives that might also be at risk? So my friend Jen is studying to be a genetic counselor. My former student Cortland is studying to be a genetic counselor. These are people who work in healthcare settings. We're going to think about what it's like to be somebody who's going to have a baby. So when you look in and zoom in here, this is the type of picture that person is holding. It is a pedigree, and we're going to talk about those in just a minute. So today's assignment is built so that I'm going to give you some notes. Then we're going to solve a few sample problems, and then you're going to work to create a pedigree using a description of 2 potential parents. And I want to tell you, if you're absent today, you may want to come into Panther Plus if you have questions. This video will not give you the answers, but it'll help read the description to you so you can think about it more carefully. Okay, so on your assignment, which is here, you're going to see that there is a place for you to take the notes I'm going to show you and a place to draw some symbols. So we're going to start here. The green stuff on the screen is what you're going to capture into this area. So here's that green stuff. Please pause the video and capture this information onto your notes. Okay, great. Now, before I show you the part that goes here and we start looking at like real pedigrees, I just wanted to tell you that family relationships and reproductive technologies come in all shapes and sizes. You might be adopted, you might have foster family, you might be being raised by your uncle or your grandma. We're going to talk really specifically about ancestors to children, and we're talking really specifically about genetic ancestors. But I also wanted to acknowledge that families come in all shapes and sizes. And when I say reproductive technology, I don't know if you've ever heard of like sperm donors or egg donors. It's possible that the person who's pregnant isn't the person whose genetic information is in the baby at all anymore because of medical advances. And that's important. There's somebody on staff at Bloomington High School South who actually has gone through this process because of a medical diagnosis. So reproductive technology means that families come in all shapes and sizes. A pedigree chart, therefore, is not a family tree. It only represents this passing down of genetic traits. And I wanted to tell you, like, most people never get a karyotype. This is that picture of chromosomes, which means that you don't actually always know all the information. Sometimes you're making a guess based on sex assignment at birth. Last, a pedigree chart shows phenotype and not genotype, unless otherwise indicated. Most people historically have not been genetically tested. And in this genetic counseling program problem that you're solving, the next thing that would happen is that people might get some testing for genes that we know might cause a phenotype. So here's a sample pedigree. This is the patient. So this is the all the siblings, the sisters and brothers of that patient. Here is the parent generation, here is the grandparent generation, and the great-grandparent generation. So, like many pedigrees don't have easily identified generations, but that's what the Roman numerals mean. And then you're going to copy down all this information here. So I'm going to go ahead and make that part of the screen. I'm going to try to make that part of the screen a little bigger so that you're able to see it. Please pause the video as soon as I get there. It's going to be any minute now. Please pause the video and make sure you've copied down that information. Okay, great. And then I just wanted to say, like, because families come in all shapes and sizes, people have come up with a lot of ways to represent different identities and different relationships on these types of diagrams. And that might be interesting for you to check out. And the all the links are here for the links where you can learn about these different types of processes. So okay, so next on the paper, there's a question about asking you to draw a pedigree. This person is a girl with a genetic medical condition. She's got two sisters and one brother. Her brother has the same condition, but her sisters do not. The kid's birth mom has the condition, but their family sperm donor, a guy who's a friend of the family, does not. And so you are going to think about using those symbols to draw the picture below. Now, one really important idea in these is this is how you draw a union of gametes, whether it's from reproductive technology or more traditional lines. This is union of gametes. Then you draw a line down and lines up above and then coming off that central thing. This is siblings. If there's a line between, that means that genetic information would pass between siblings. And in our problems, that's not happening. So if you have problems with this question, please come see me and I would love to help you. Now, the next thing we're going to do is try to think about whether or not three different cases could be dominant, recessive, or both. So here we go. If the condition for case one is dominant, that means that like the guinea pig, let me get the guinea pig picture back here. Like the guinea pig, that means that you've got an allele where only one allele causes that to happen. Well, it doesn't matter. This allele could be another big H or it could be a little h as shown here. And so that's why there's a question mark here. But if there's a big A and it's a dominant allele that is giving this person this condition, that means there would have to be a dominant allele up here to inherit. At least one parent would have to be big A blank, at least one of these ancestors. So it's not dominant. This condition can't be dominant. And so that's how you think about it's whether or not it's dominant or recessive. Now, if this condition is recessive, you can imagine what the genotypes of these people might be. Indeed, they are going to end up, you could imagine that people whose genotype was big A blank and big A blank, that means they'd still have one allele to make the protein that gives them the typical phenotype. And indeed, in order to get that little a, they have to be heterozygotes, like we learned about with the guinea pigs. They have to be big A, like that. So for case one, it can be recessive and it can't be dominant. So you're going to write genotypes below each person, big A's or little a's, and then you're going to write a few words about why you have answered it the way you have answered. It could be yes or no, it could be no, yes, it could be yes, yes. In this particular case, case one has to be, if we don't get new mutations, a recessive phenotype. So that's what we're doing there. You're going to do the same thing here. You're going to try dominant alleles. If this is a dominant alleled person and this is a dominant alleled person, and you don't know whether it's big A or little a for either of these people, are you able to get little a people? Same thing here. If this is little a, and this is little a, and you need to pass on a dominant allele, a capital letter, can you do that? And so that'll help you answer this one. Now, in this particular case, you can do both. It turns out both dominant and recessive are possible, so I'll give you the answer, but you have to be able to write down which letters would go with which person. That's the goal there. Okay, so the rest of today's assignment is the pedigree assignment. It's the geneticist problem. So like I told you, you're going to explain to a couple the probability of their child developing an autosomal genetic condition if their gametes are both used. Because little is known about the genetics of this condition, you're also going to characterize it to aid other medical personnel and geneticists. So you've got some patient information. We're calling them spouse one and spouse two. People who come in to do genetic counseling don't need to be spouses, but that's the problem that's been set up here. And you're going to see a lot of different information. You're going to make a pedigree by using this information. I would start on a whiteboard or on a separate piece of paper before you draw the pedigree in this space. We really think it's very easy for people to get frustrated and do a lot of white erasing. Again, come into Panther Plus if you would like support. Once you do that, it should be pretty obvious to you whether the condition is dominant or recessive. And you're going to take some notes about why you know that. It's important in your description to use specific relationships to support your claim. Well, if grandpa were little a, that would mean that spouse one would be which would, like that kind of stuff here. All right. So the last thing you need to do is make sure that every single person has a genotype. Now, for one or more of the people in this pedigree, you might use an example like we did of like big A blank. For many of them, though, you'll have like this, but for many of them, if you have a dominant allele, a dominant condition, you'll have to fill in the little letter with the little a, the recessive allele. So the last thing you're going to do is show a Punnett square, the ratios of the genotypes, like 3 to 1 or 1 to 1, dominant to recessive. So if it's 50-50, if your Punnett square is 50% dominant phenotype and 50% recessive phenotype, that's what you'd write there. But this is the genotypes, and I will tell you more about doing the genotypes on the slides. Let me find the slide I was going to make to do that. Here we go. Cool. So when we talk about ratios, we always go one here. We always go in this order. So a genotypic ratio is the number of squares that are big A to the number of squares that are heterozygotes to the number of squares that are little a, and I'm putting those colons in between. You always start with the dominant genotype. In phenotype, when you're doing this type of problem, we won't be doing blood type in this particular situation, but a phenotypic ratio, you would move, excuse me, in a phenotypic ratio, you would do the ones with the dominant phenotype to the ones with the recessive phenotype. Yeah. So that's how it works. And I hope that that helps you think a little bit about how you're going to make those ratios. Sometimes it's 400 to what, like 1 to 0, everybody would have a dominant phenotype and there wouldn't be any recessive phenotypes. And that's kind of how those look. As you work, just a reminder, it's going to be okay to make mistakes. And it's important that you make those mistakes so that you can learn really deeply about pedigrees. So there's a question at the end that asks if spouse one is heterozygous, what's the probability their kid will develop the condition? If spouse one is homozygous, what's the probability their child will develop the condition? And there aren't any lines on this assignment because you have to draw a pedigree and then explain your thinking. And that'll take different space for different numbers of people. Okay, so if your assignment is not done, that's a sign that you need to finish this assignment. I'm just going to say it is due as homework if you didn't finish. That's how it goes here. So if you didn't finish today's assignment, that is now homework. For this particular assignment, you might want to come to Panther Plus next week so that you can get your needs met. And then this is just the end of class stuff that they had to take care of. I hope you're doing well out there. Just a reminder that we are going to have our first quiz. There we go. Because we take quizzes on Friday. This is a Canvas quiz, and you will need to make sure that you have your computer. So just a reminder, we take quizzes starting this week. All right, that's it for me. Take care out there. See you soon. Bye.